Terrence Howard, the guy who interviewed me for Rolling Stone, told me that Terrence Howard is like a legitimate genius. Like, he's like, you talk to the guy is absolutely brilliant.
Maybe he figured it all out.
It wasn't like nonsense. I think he got high as on DMT. That's what it sounds like. He's talking about
figured it all out. Yeah, it does sound like that, right?
100%, yeah.
Did you see the guy from Empire's speech, like interview?
Yes.
Wow.
Yes.
Like, that seems almost like he's not pretending. Like, if he's pretending, he's doing a better job acting than Joaquin Phoenix.
What is this? Terrence
Howard, yeah, you saw it.
The flower of life. 6,000-year-old secret. 6,000 years, mankind has been trying to decipher this one little thing called the flower of life.
Terrence Howard just uncovered something that can completely overhaul our very existence, and Joe Rogan has confirmed it. For thousands of years, people in power have concealed this knowledge in the shadow of time, for fear of the upheaval it could bring. However, with these shocking revelations and theories,
But the thing that I was most spiritually connected to, that was my driving force, was physics. It was wondering how the universe really came to be.
Howard is ready to confront any expert in chemistry, physics, astrophysics, cosmology, or biology.
You know, so acting in physics, in physics, when two things are drawn to each other, it's because they are of similar charge.
What evidence backs these claims? How did Joe Rogan react to them? Join us as we delve into the truth of how Joe Rogan confirms Terrence Howard's theories. Howard's fascination with scientific theories. Recently, Joe Rogan was captivated by an interview with Terrence Howard on his podcast. Howard, known primarily as an actor from Empire, has a keen interest in complex scientific theories. However, he has also starred in many notable movies, including Winnie Mandela, Ray, Lackawanna Blues, Crash, Four Brothers, The Brave One, and Prisoners. Howard also played James Rhodey Rhodes in the first Iron Man film. In addition to his acting career, he released his debut album, Shine Through It, in September 2008. But that's not what we are here to talk about. Howard's thoughts on ancient concepts like the flower of life, wave conjugations, and hidden frequencies fascinated Rogan. The actor's ideas, which he passionately elaborates, aim to redefine our understanding of the universe.
Wondering how the universe really came to be.
In his podcast with Rogan, he spoke about his lifelong passion for physics and his deep connection to the flower of life, a symbol that has intrigued him for decades. Despite facing skepticism, he remained dedicated to his quest for understanding. He compared himself to historical figures like Leonardo da Vinci, claiming that he has solved mysteries that have puzzled scholars for centuries. In a surprising revelation, Howard shared a vivid memory of becoming conscious while still in his mother's womb at 6 months old.
I woke up inside my mother's womb at about 6 months of age. I woke up inside of there.
He described the experience of awareness and the determination to remember this early consciousness. Rogan related to this by recounting his own experiences with his unborn son, emphasizing the potential for awareness even before birth. Howard's exploration of the flower of life is not just a casual interest, but a significant part of his intellectual journey. This symbol has deep historical significance, found in various ancient cultures around the world. In Egypt, it was discovered in the Temple of Osiris, molecularly burned into the wall over 6,000 years ago.
This symbol was found in the Temple of Osiris in Egypt, and it had been molecularly burned into the wall. And it's 6,000 years old.
This same symbol also appeared in forbidden temples in China, beneath the paws of foo dogs.
The forbidden temples in China, sitting under the foo dogs, and the foot on it, the flower of life.
Symbolizing the belief that whoever understood the flower of life could unlock the secrets of the universe. Great minds throughout history, such as Leonardo da Vinci, Isaac Newton, and Pythagoras, were fascinated by the flower of life. They believed it held profound secrets about the nature of reality. Da Vinci spent much of his life trying to understand its mysteries, while Newton and Pythagoras sought to decode its meaning in their own ways. However, their efforts were constrained by their two-dimensional perspective, preventing them from fully grasping its complexities. These scholars were attempting to bring the flower of life to life.
And I fell in love with this thing called the flower of life. You guys know Da Vinci.
Believing that within its intricate design lay hidden shapes and forms that could reveal the fundamental truths of existence. They managed to extract certain concepts and shapes, such as the platonic solids, but their understanding was limited by their adherence to two-dimensional thinking. Howard also believes that understanding this symbol can unlock secrets about the nature of reality, the universe, and the relationship between energy and matter. His theories challenge conventional scientific thinking and propose that ancient wisdom holds the key to modern scientific breakthroughs. the flower of life, according to Howard, is more than just a geometric pattern. It is a blueprint of the universe that has the potential to reveal fundamental truths about existence. This perspective invites us to consider how ancient knowledge and modern science might intersect to provide deeper insights into the nature of reality. Why Howard thinks 1 times 1 isn't 1. According to Howard, thinkers who have tried to unravel the flower of life before him could not unlock the symbol's full potential because they viewed it within the confines of flat, straight-line geometry. He argues that this symbol should be understood in terms of curved space, reflecting the natural curvature of the universe. To illustrate his point, Howard discussed how Da Vinci spent much of his life trying to decode the flower of life, but was hindered by his attempts to make straight lines bend. Howard contends that the shortest distance between 2 points is actually a curved space, not a straight line. This insight, he believes, allowed him to see the flower of life in a new light, potentially unlocking its hidden secrets. In a striking demonstration, Howard explained a mathematical exercise involving the square root of 2. He asked listeners to use their calculators to square and then cube the number, revealing a consistent loop. This exercise, he claimed, exemplifies the idea of a loop in mathematics, a concept that he believes is fundamental to understanding the universe. In his exploration of the nature of the square root of 2, Terrence Howard delves into the deeper meanings and implications of numbers and their historical journey from concrete reality to abstract imagination. Just as the symbol 2 signifies the combination of 1 plus 1, the symbol for the square root of 2 satisfies the equation x times x equals 2. This exploration invites us to question the traditional ways we understand and use numbers. Historically, the development of numbers has moved from natural numbers like 1, 2, 3 to integers, including negative numbers, then to rational numbers, algebraic numbers, real numbers, including limits, and finally to complex numbers where x times x equals -1. This progression shows our increasing abstraction and complexity in understanding numbers. However, we often take these number systems as universal truths, applying them universally without questioning their foundational assumptions. To understand the square root of 2, Howard says we must look back to the time of Pythagoras and his followers, who were exploring geometry. One significant focus was the right triangle, particularly through what we now call the Pythagorean theorem. This theorem states that in a right triangle, the square of the hypotenuse, the side opposite the right angle, is equal to the sum of the squares of the other 2 sides. This is the genesis of a significant mathematical concept, the square root of 2. However, Howard argues that there is a fundamental flaw in the traditional interpretation of this equation. When we calculate 1 times 1, we get 1. But what about the units? The product of a unit length with another unit length should have units of area, not length. This oversight leads to a misunderstanding that has been perpetuated for thousands of years. Howard's exploration suggests that if we reconsider our assumptions about numbers and their units, we might uncover deeper truths about the universe. He urges us to question the artifacts of number history and their application to various fields. By doing so, we open our eyes to new perspectives and possibilities. Howard's understanding of platonic solids. One of Howard's most provocative claims is that many foundational principles of science and mathematics need a complete re-evaluation. He criticizes the use of platonic solids, which have long been used to model the building blocks of matter, suggesting that these shapes are merely approximations and do not fully capture the true nature of the universe. These platonic solids, rooted in ancient traditions, hold profound symbolism and practical applications, serving as templates for understanding geometric relationships. The flower of life, the sacred geometric pattern, forms the basis for constructing these solids and encapsulates essential information about the universe. Howard's mention of the Tetrahedron, a form of the Teton, sheds light on ancient wisdom passed down through generations. Across various cultures worldwide, stories and symbols dating back thousands of years echo the significance of these geometric forms. The Tetrahedron, in particular, holds immense value due to its geometric properties. Exploring this shape, particularly in the realm of geometrics, sheds light on its practical applications and ancient roots spanning various traditions worldwide. The Tetrahedron holds a special place in spiritual and scientific contexts, often regarded as the fundamental shape of energy. It offers a simple yet profound way to divide space, serving as a cornerstone for understanding geometric relationships. Across cultures and civilizations, spanning from ancient times to the present day, the Tetrahedron emerges as a symbol of cosmic significance. Howard even questions basic mathematical postulates, such as the idea that 1 times 1 equals 1, as we already discussed. He argues that this principle ignores the multiplicative effect of energy interactions, which should logically result in an increase, not just a replication of the initial quantity. To further illustrate his point, Howard gave a vivid example using currency. He asked the audience to consider what happens when you multiply different denominations. For instance, a dime times a dime or a dollar times a dollar. According to Howard, traditional banking can interpret these multiplications in various ways, leading to different outcomes. This inconsistency, he believes, stems from the flawed principle that 1 times 1 equals 1. He suggests that this mathematical oversight has stunted scientific progress and created inconsistencies in our economy. Howard plans to elaborate on this idea in his upcoming book, Does a dollar times a dollar equal a dollar or $2? In this book, he not only challenges the traditional interpretations of platonic solids, but also introduces the concept of wave conjugations, which he believes provide a three-dimensional understanding of the world. Howard emphasizes that our current mathematical models are two-dimensional, akin to black and white stick figures, while his theories offer a multicolored, three-dimensional perspective. He believes this shift in understanding could revolutionize various fields, from physics to engineering, and even reshape our philosophical views on existence. The relationship between the flower of life and the tetrahedron. The significance of the flower of life extends beyond its symbolic value. It provides a practical framework for approximating the platonic solids, essential geometric forms that underpin our understanding of the cosmos. By connecting the dots and tracing the lines within this sacred pattern, we gain deeper insights into the geometric principles governing our reality. The tetrahedron, in particular, holds immense significance in measuring time and mapping three-dimensional space. Its unique properties allow us to unravel the mysteries of geometry and navigate the complexities of the physical world. Through the triangulation of points and the unfolding of shapes, we gain a deeper understanding of the interconnectedness of all things. The tetrahedron holds significant implications across various fields, from ancient architecture to cutting-edge cosmology. By combining 30 tetrahedrons on their faces, a remarkable phenomenon known as a child chain unfolding occurs, giving rise to the helix. This intricate interplay of shapes and dimensions highlights the inherent harmony and complexity embedded within geometric structures. Moreover, the significance of the tetrahedron extends beyond mere mathematical abstraction. Its geometric properties have practical applications in diverse fields, from mapping space-time to understanding the dynamics of energy and matter. In ancient civilizations, such as the Mayans and Egyptians, the tetrahedron played a pivotal role in architectural design and astronomical calculations. Monuments like the Great Pyramid of Giza exemplify the meticulous alignment with celestial events, demonstrating the profound understanding of geometry and astronomy possessed by ancient cultures. Furthermore, contemporary research, led by scholars like Dr. Nassim Haramein, explores the role of the tetrahedron in shaping our understanding of the cosmos. Haramein's work with the Resonance Science Foundation delves into the intricate geometry of space-time, suggesting that the universe itself may be structured in a tetrahedral grid pattern. Terrence Howard's insights into the dynamic nature of the universe, as depicted in the Rogan podcast, offer a compelling perspective on cosmic expansion and contraction. The cyclical flow of energy, similar to the rhythmic breathing of the universe, shapes the formation of galaxies, stars, and planetary systems. Moreover, the concept of vortex formation, illustrated through simple analogies like spinning coffee grounds in water, elucidates the fundamental principles of organization and structure in the cosmos. From swirling galaxies to spinning planets, the inherent tendency of matter to organize itself into spherical or spheroid shapes reflects the underlying harmony of natural processes. The pendulum effect in the universe. At the core of Howard's theory is the idea of wave conjugations. He posits that all energy in the universe is expressed in motion, and all motion manifests as waves, which are inherently curved. This perspective contrasts with traditional Euclidean geometry, which relies on straight lines and flat planes. According to Howard, the idea that all waves are expressed in curves ties into the concepts of gravity and event horizons, these points of immense gravity where not even light can escape. Traditional physics has often relied on the concept of zero, viewing it as a point between positive and negative. However, this doesn't align with the natural world as Howard sees it, where nothing is ever truly still. Everything in the universe is in constant motion, interconnected. If one thing were to be still, everything connected to it would also have to be still, which is impossible. When stars, such as our sun, age, and eventually supernova, they expand and eject particles into space. These particles travel further and further away until they collide with particles from other stars, creating pressure conditions. This interaction results in phenomena like stellar nurseries, where new stars are born. It's all about waves and particles meeting and interacting at specific points, creating new conditions and forms of energy. Our traditional understanding of physics complicates things with oversimplified concepts. But when we look at the universe's natural behaviors, its constant motion and balance, we see a more complex but accurate picture. By embracing the natural curvature of space, Howard suggests he has discovered new wave interactions that explain the behavior of fundamental particles and the structure of the cosmos. Howard questions the very existence of straight lines in nature, urging us to reconsider our foundational geometrical assumptions. If this perspective is correct, it challenges many conventional scientific views, suggesting that our understanding of the universe might need a significant shift. But the patterns of the universe and the evidence support this dynamic and interconnected view of reality. Limitations of human perception. According to Howard, the universe operates on electricity, which we sometimes perceive as magnetism when it's in a different state. We often think of it in dual terms, the radiative side being the feminine aspect and the contractive side being the masculine. This balance between expansion and contraction is fundamental to how the universe works. Electricity, for example, constantly seeks a balanced state, but once it achieves this balance, magnetism takes over and pushes it out of equilibrium, creating a pendulum effect. This constant back-and-forth motion is like the universe's way of breathing in and out, a phenomenon observable in everything from celestial bodies to our cells, which are primarily composed of water. Water, or hydrogen, is characterized by 12 opposing vortices, creating this constant motion and interaction. Howard delves into the realm of chemistry and physics, presenting a thought-provoking view of matter and motion. He suggests that chemicals are essentially the result of electrical or magnetic motion, emphasizing that matter is just a manifestation of these fundamental forces. He also introduces the idea that each element in the periodic table is simply a manifestation of different pressure conditions, leading to various crystalline structures. For example, hydrogen exhibits similar tonal conditions to other elements like carbon and silicon, highlighting the interconnectedness of the elements. Howard also challenges conventional perceptions of elemental relationships, suggesting that our understanding may be limited by our cognitive and physiological processes. He discusses how altering the conditions under which an element exists can result in different manifestations, citing the transformation of carbon into diamonds as an example. This transformation underscores the idea that despite changes in appearance, the fundamental nature of the element remains unchanged. Expanding his perspective, Howard delves into the limitations of human perception, highlighting our restricted view of the electromagnetic spectrum. He suggests that our perception, limited to less than 1% of the total spectrum, influences our understanding of the world. Terrence philosophizes about the cyclical nature of existence, challenging the notion of death and emphasizing the eternal cycle of life and energy exchange in the universe. Howard's exploration extends to the concept of electric charge, proposing a reevaluation of its traditional understanding. He suggests that when an entity loses its electric charge, it seeks a high-pressure condition, where centrifugal force dominates, challenging the conventional notion of electric charge as solely negative. There is no void in space. Howard's theories extend into the concept of the void, the seemingly empty spaces between particles. Contrary to conventional wisdom, Howard posits that these voids are not empty, but filled with fundamental particles and energy signatures that hold the universe together. By analyzing the patterns within the flower of life, Howard claims to have identified these hidden particles, which he believes have eluded detection by traditional methods used at facilities like CERN. The energy signatures observed at particle accelerators like the Large Hadron Collider at CERN also bear a striking resemblance to the patterns found within the flower of life, hinting at a deeper connection between the microscopic and the cosmic. He explained that the in-between spaces, like the void between the Earth and the Moon, are filled with something, contrary to the common belief that they are empty. According to Howard, these voids contain elementary fundamental particles, which he has been able to match with energy signatures he discovered through his studies. He claims to have identified around 70 different elementary particles, along with secondary particles that seem to form their own systems. Howard has taken his findings to institutions like Oxford, hoping to have his theories tested and validated. Howard's discussion about the flower of life delved into its historical significance and its potential to reveal new scientific truths. This ancient symbol, found in numerous cultures, has captivated great minds throughout history. Howard believes that unlocking the secrets of the flower of life could revolutionize our understanding of the universe. He invites others to examine his work and test his hypotheses, confident that they will find all the fundamental particles that have eluded modern science. How Howard's curved lines theories can improve technology. In a recent discussion, Terrence Howard explored the fascinating intersection of geometry, music, and consciousness, challenging conventional scientific and mathematical principles. He emphasized how modern advancements in architecture and aviation have embraced aerodynamic, three-dimensional designs, yet our mathematical models remain rooted in two-dimensional Euclidean concepts. To truly advance, Howard argues, we need to rethink these foundational ideas. One of the most intriguing aspects of Howard's discourse revolves around the shift in musical tuning from 432 Hz to 440 Hz. While this change might seem minor, Howard believes it has significant implications for human consciousness and well-being. He argues that even slight variations in frequency can have substantial effects on our physiological and psychological states. Talking about math and calculators, Howard noted that calculators seem to think everything's just on a straight line. He compares them with old pianos, back before they figured out how to play with sound. They had 12 notes and just kept repeating them, instead of letting the music expand naturally. Now, if you're looking at something like the periodic table, trying to understand the elements, you're missing out on a bunch of possibilities. Titanium, rubidium, cesium, they're all part of the picture, but the calculator's stuck on repeat, only seeing those same old 7 tones. We're meant to keep growing and expanding, but the math we're using doesn't account for that. Walter Russell also talked about this idea of everything coming together in 4 dimensions. He saw the beauty in it, but even he was a bit trapped by the idea of straight lines. But truly, when you zoom in close enough, even the straightest line starts to look pretty wiggly. Our senses can fool us into thinking we see straight lines, but in reality, everything's a bit more curved than we realize. That's why Howard thinks it's funny that we keep building things with straight lines. Take homes, for example. They're like flat boxes, and then we wonder why they keep getting blown over in hurricanes or tornadoes. But what if we built them more like mushrooms, following the curves of nature? They'd probably hold up a lot better. The same goes for airplanes and boats. They've figured out that curves work better than straight lines when it comes to moving through air or water. Recently, Howard has been working on new music tuned to 432 Hz, which he believes is a more natural and harmonious frequency. This idea aligns with ancient practices and the work of thinkers like Pythagoras, who sought to understand the deep connections between mathematics, music, and the cosmos. Howard claims to have made discoveries related to the flower of life, which he believes reveal new wave conjugations, patterns that describe the fundamental interactions of energy and matter in the universe. Howard explained that by re-examining the flower of life with his curved lines perspective, he has uncovered new insights into the in-between spaces that hold everything together. Beyond the physical and mathematical aspects, Howard delves into consciousness and its connection to the universe. He suggests that the flower of life and the wave conjugations it reveals are deeply linked to how we perceive and interact with reality. By understanding and aligning with these principles, Howard believes individuals can tap into a deeper connection with the universe and unlock their creative potential. This perspective echoes ancient philosophies and spiritual traditions that emphasize a profound unity between the self and the cosmos. Debated theories by other scientists. John Worrell Keely is a fascinating figure whose work dives deep into the realms of unconventional science, much like Nikola Tesla's work with scalar waves, but in a different context. If you want a mainstream account of Keely's life, his Wikipedia page is a good starting point, though it might come across as biased. Keely was an inventor in the late 1800s who claimed he could produce a motor using etheric force and resonance. Despite years of efforts and debates with shareholders, his inventions were eventually deemed failures because he couldn't demonstrate them accurately. Keely faced a challenge from the scientific community to prove his theories, but he ignored it. Even Tesla and Edison were invited to review Keely's work, but both declined. One of his engines surfaced in the 1980s and was purchased by Dale Pond, who tried to reverse engineer it. There's even a YouTube video about this. In the video, Dale Pond explains how he managed to get one of Keely's motors working by placing it in a bathtub filled with water. It wasn't as effective as Keely had claimed, but it did show some functionality. Pond concluded that the engine ran on a combination of techniques harnessing scalar waves, similar to what Tesla described, and a plumbing effect known as the water hammer effect. Pond speculated that Keely might have withheld his technology due to fears of its potential misuse, thinking it could be destructive if it fell into the wrong hands. This was long before the atomic age, which suggests Keely might have been ahead of his time in understanding the power of his inventions. Keely's work, like that of Tesla and other pioneers, remains shrouded in mystery. There are parallels between Keely's obscured inventions and the mysterious disappearance of Tesla's work. Dale Pond went on to explore sympathetic vibratory physics, which Keely had been working on. This concept is also a foundation for Terrence Howard's theories. Rupert Sheldrake's concept of morphic resonance is another fascinating area to explore. Sheldrake proposes that cells tap into a morphic field of information, akin to an internet for life, to perform their functions. These theories interconnect in intriguing ways. It's worth noting that figures like Tesla, Keely, Russell, and Sheldrake have all faced ridicule from established industries and conventional thinking, hinting at potential truths overlooked by mainstream science. Walter Russell's periodic wave of elements theory sheds light on how every element resonates at a different frequency, affecting our perception of them. This notion aligns with the idea that everything, from gravity to light, exists on a spectrum of energy. The frequency of these waves determines their characteristics, much like how the tone of music varies depending on its frequency. Noble gases, with their stable electron shells, remain unreactive, serving as examples of stability amidst change. Understanding how electrons act both as particles and waves is fundamental to grasping the intricacies of quantum science. Pressure conditions play a crucial role in determining how elements interact, whether through fusion or fission. These concepts illustrate the interconnectedness of various phenomena, from galactic structures to microscopic particles, inviting further exploration into the mysteries of the universe. Terrence Howard creates a shift. Despite poor educational background, Howard shared a personal anecdote about his early fascination with these ideas, suggesting that he might have been working on them from a past life. While he acknowledges this might sound unconventional, he points out that energy doesn't die, it simply transforms. This belief in the continuity of energy underpins his view that life is an eternal process of learning and growth. Reflecting on his own journey, Howard noted that he did not excel in traditional education, graduating high school with a 1.6 GPA. Instead, he was self-educated through his relentless curiosity and exploration of these profound concepts. He hopes that institutions like Oxford will take his work seriously and help validate his theories, potentially leading to significant advancements in our understanding of the universe. Terrence Howard's theories call for a fundamental shift in how we approach science and knowledge. He advocates for a reassessment of mathematical and scientific principles, urging us to move away from rigid, linear thinking towards a more holistic, integrated understanding of the universe. Howard challenges educational and research institutions to embrace this new paradigm and rigorously test his theories. He is confident that such scrutiny will validate his discoveries and lead to broader acceptance of the ideas he has championed. However, whether or not Howard's ideas will withstand rigorous scientific validation remains to be seen. The scientific community often requires extensive evidence and peer review to accept new theories. Despite this, Howard's contributions to the discourse on the nature of reality are undeniably thought-provoking and inspiring. His willingness to challenge conventional wisdom and explore new frontiers in science and mathematics is a testament to the power of curiosity and innovation. By questioning long-held assumptions and proposing alternative viewpoints, Howard encourages us to think more deeply about the world around us and our place within it. Thanks for watching. See you in our next video.